everyone. If you're getting ready for your phlebotomy certification, you are in exactly the right place. Today, we're going to do a deep dive into the evacuated tube system, or ETS. We'll break down everything you need to know to absolutely ace your exams, and, more importantly, to start your career feeling confident and prepared. So, let's jump right in.
So, here's what we've got lined up. First, we'll cover why the ETS is the industry gold standard. Then, we're going to get hands-on with your toolkit, piece by piece. After that, we'll walk through a perfect draw, step by step. We'll also cover how to troubleshoot when things don't go as planned, figure out when a syringe is actually the better choice, and we'll finish up with a final exam checklist to make sure all these key facts are locked in.
So let's kick things off with the basics. The evacuated tube system isn't just a way to draw blood, it's the way, the one that the Clinical and Laboratory Standards Institute, or CLSI, says is best. And we're about to find out exactly why.
Okay, if there's one thing you take away about the ETS, let it be this. It's a closed method of collection. That's the magic phrase right there. It means the entire system is designed to keep the blood sample from being exposed to the air and, just as importantly, to keep you from being exposed to the blood sample. It's a design that's built from the ground up for safety.
And you'll see a theme here. Everything comes back to safety and accuracy. Because it's a closed system, it meets all the big safety standards from places like OSHA and the CDC. That preset vacuum, it's genius. It pulls in the exact amount of blood you need, ensuring that critical blood-to-additive ratio is perfect every time. And of course, being able to draw multiple tubes from just one stick, it's way more efficient and a much better experience for the patient.
Okay, so now let's get into the fun stuff, the actual tools. In Section 2, we're going to unpack your toolkit. You have to think of the ETS as, well, a system. Each part needs the others to work correctly, and knowing how they fit together is key to a perfect draw.
So, it all boils down to these three key players that have to work together. First, you've got the multisample needle. It has a point for the patient's vein and a shorter, rubber-sleeved point on the other end. That little rubber sleeve is an amazing safety feature. It stops blood from dripping out when you switch tubes. Second is the tube holder, that plastic barrel the needle screws into. And third, you have the evacuated tubes themselves, each with that perfect vacuum and a specific additive for whatever test is needed.
Okay, listen up because this is a huge safety point, and you can bet it'll be on your exam. It might seem like parts from different brands fit together, but you should always use components from the same manufacturer. The threads on the needle and the holder might not be a perfect match, and under pressure you risk what's called a tube pop-off. And trust me, that's exactly what it sounds like. It's a mess, it ruins the sample, and it's a huge safety risk.
All right, this chart right here, this is basically your new best friend. You're going to want to memorize this inside and out. It lays out the correct order of draw and tells you everything about each tube, the stopper color, the additive inside, how many times to invert it, and where it's going in the lab. Pause here if you need to, because knowing this chart is absolutely essential.
You know, one thing that trips a lot of students up is the difference between serum and plasma. So let's clear that up right now. It's actually pretty simple. Serum tubes, like your red or gold tops, have a clot activator. They're designed to make the blood clot, so when you spin it down, the liquid that's left over, the serum, has no clotting factors left. Plasma tubes, like the green tops, have an anticoagulant like heparin. They do the opposite. They prevent the blood from clotting, so the liquid portion, the plasma, still has all its clotting factors.
Okay, if you memorize one thing from this entire explainer, please let it be this. The light blue top tube, which is used for coagulation tests, has to be filled perfectly. It's made for a super precise 9-to-1 ratio of blood to additive. If you underfill this tube even by a little bit, the test results are worthless. This is a massive patient safety issue, and I can almost guarantee you'll see a question about it on your exam.
Okay, so we've got our tools, we know our tubes, now let's put it all together. Section 3 is all about that perfect draw workflow. This is the sequence you need to follow every single time, without exception. I want you to think of this workflow as your pre-flight checklist. You do it the same way in the same order every single time. It starts with getting your tray ready and identifying your patient, always with at least 2 identifiers. Once you're in the vein, you pop in your tubes in the right order. And here's a key step. Release that tourniquet as soon as you get blood flow. As each tube fills, you invert it right away. After the last tube is out, withdraw the needle, and the very first thing you do, before anything else, is activate that safety feature. Then dispose of the whole needle and holder unit, and finally label every tube right there at the bedside.
And that brings us to a super important point about technique. Notice the word is invert, not shake.
Shaking is just way too violent. It literally bursts the red blood cells. That's called hemolysis, and that can totally ruin the sample. A few gentle inversions, like turning a bottle upside down and back, is all you need to mix the additive correctly.
All right, on to section 4, troubleshooting. Because, let's be real, not every draw goes perfectly. Knowing what to do when things don't go as planned is what separates a good phlebotomist from a great one. It's all about staying calm and working the problem.
So, picture this. You've got a perfect stick, you pop in the tube, and crickets. Nothing's happening. What's your first move? Your first move always is to grab a new tube. It's really common for a tube to just lose its vacuum. If a new tube doesn't work, then you can try making a tiny adjustment to the needle angle or pulling back just a little. The bevel might just be up against the wall of the vein. If you think the vein collapsed, take the tube out to release the pressure and just give the vein a second to refill. This is one of those rules with zero wiggle room, and it is a major NHA exam alert. If a tube with an additive is underfilled, especially a light blue or a lavender, the sample is compromised. The ratio is wrong, the results will be wrong. Period. There is absolutely nothing the lab can do to fix it. The only solution is a recollect.
So we've been talking all about the ETS, but it's not the only tool in our kit. Sometimes it's actually not the best tool for the job. In this section, we'll talk about when and why you'd reach for a syringe instead.
A syringe is your go-to for patients with very small or delicate veins, the kind that might just collapse under the vacuum pressure of an ETS tube. After you perform the draw, the transfer process is all about safety. First thing, activate the needle safety feature and get it into the sharps container. Then you'll screw on a sterile transfer device. This is key. It keeps the system closed. Then all you do is puncture the top of each tube and let its own vacuum do the work. It'll pull the blood right out of the syringe, no effort required.
And here is a huge flashing warning sign. I cannot say this enough. Do not push the plunger. You have to let the tube's vacuum fill it naturally. Forcing the blood in is a triple threat. You'll cause hemolysis, you can create a fine spray of blood called an aerosol, and you might even pop the stopper right off. It's dangerous and it ruins the sample. Just let the vacuum do its job.
Whew, okay, we have covered a ton of ground, so let's bring it all home with our last section, your exam success checklist. Think of this as the ultimate cheat sheet of things you absolutely have to know before you walk into that testing center. First up, let's talk about additive carryover. This is the big why behind the order of draw. So if you draw a lavender tube before a green one, a tiny bit of the EDTA from the lavender tube can get into the green tube. And boom, your patient's results for things like calcium and potassium are totally wrong. Following the order of draw prevents this from ever happening.
All right, let's do a quick lightning round of exam alerts. These are things you just need to commit to memory. SESIP, that stands for Sharps with Engineered Sharps Injury Protection. Bedside labeling, it's not optional, it's mandatory. Inversion counts, know them by heart. Expired tubes, never, ever use one. And finally, plastic red top tubes are not plain, they have a clot activator inside.
Finally, let's really lock this in by connecting the what to the why. When you understand the reason behind a rule, it's so much easier to remember. We discard the holder and needle together to avoid getting stuck by the contaminated threads inside. We let the vacuum fill the tube to get that perfect ratio. And we use parts from the same brand to prevent those dangerous leaks and pop-offs. It all comes back to safety and accuracy.
Okay, so as we wrap this up, I want to leave you with a question. We've talked about all these potential errors that can happen before a sample ever reaches the lab. Things like misidentifying a patient, drawing out of order, or labeling incorrectly. Knowing what you know now, which one of those errors will you make your personal mission to prevent? Every single draw, every single day. That commitment, that personal standard of excellence, that's what's going to make you an amazing phlebotomist. You've got this. Good luck with your studies.